You could distribute through that x into every single term, but in the general sense, that's just taking the general term and multiplying it by that x. So x times x to the n is x to the n plus 1. So that's why that numerator is x to the n plus 1. The denominator is just n factorial. Does that make sense? Cool. So that's how easy that is. Is there anything else that I want to talk about before I open it up to you guys?
Can you talk about the elements of it?
Sure. Well, do you want me to just do the one from your homework?
Yeah, that'd be great. Number 9.
Cool.
If you can do the 10 too, that would be helpful.
Are we talking about bands? Okay, so listen, everyone listen. Hey, these are my last few days of teaching, so let's make them good and memorable. New material, I should say. So, are you ready? Okay, there are two approaches here. Because they're asking us to find a Maclaurin series for this, I could start with the approach of, oh, okay, let's look for a pattern for the nth derivative of f evaluated at 0. So this is one approach, and then I'm going to go through. So for n equals 0, 1, 2, 3, 4. So here we have ln of 1 minus x squared. And that evaluated at 0 is just ln of 1, which is just what? 0. So then, every n after 0, the ln is gone, and we're only going to have, or be left with a rational expression for the nth derivative of f of x. So let's go through what is the first derivative of ln of 1 over, or sorry, ln of 1 minus x squared. So we would start with 1 over 1 minus x squared times negative 2x, right? Or that's just going to be negative 2x over 1 minus x squared. When x is equal to 0, what does that yield? 0. Next. So the reason why I'm thinking is, I don't know, do I call f prime of x negative 2x over 1 minus x squared, or do I call it negative 2x times 1 minus x squared to the negative first? Let's start with the second one. Let's see if that makes it easier. So what's the second derivative of f of x? Well, that's going to be first times the derivative of the second plus the second times the derivative of the first. Is that better if I do it this way? Gosh. So right now, what's going on in my head is kind of painful doing it this way. We have the other way that I haven't even talked, well, I did talk about that earlier, but I haven't mentioned yet during this problem. But, right, so then for this, when x is equal to 0, this whole first term is going to be 0, and then it's just going to be negative 2, right? That f double prime of 0 equals negative 2. Because this whole, when x is 0, this whole thing is 0. When x is 0, that's 1 times negative 2, which is negative 2, right? So then over here, you're going to have negative 2, but then for this, it's like all of that stuff down there. Or you could have done low high minus high low over the square of what's below. Anyway, it looks a little bit complicated, but really we're looking for some pattern that's going to develop here, and really you're going to see a pattern for the nth derivative of f of x, and then when you plug in 0 in for the pattern over there. So remember, this is where I always said pattern. But anyway, this is one way to approach that. The other way is knowing so we know that 1 over 1 minus x is just the summation. So I'm going to say, should I do another color? Maybe I'll do another color. So, or we know that 1 over 1 minus x is equal to the summation as n goes from 0 to infinity of x to the n. And because f prime of x is, we already have that there, negative 2x over 1 minus x squared. Well, that negative 2x, I can just multiply in, just like I did with x times e to the x. So let's just look at 1 over 1 minus x squared is just going to be the summation as n goes from 0 to infinity of x to the 2n. Do we see that? Does anybody need more explanation? Because all I'm doing is I'm replacing this x with an x squared, so I'm replacing that x with an x squared, so x squared to the n is also known as x to the 2n, right? But because I'm looking, oh, that kind of resembles this, so then I would say negative 2x times 1 over 1 minus x squared is equal to negative 2x times this, which is just equal to, let's call it negative 2 times the summation as n goes from 0 to infinity of x to the 2n plus 1. Now, what if you're saying, okay, great, I see that, but that doesn't give us the answer, Mr. Roller. That's not what I had in the back of the book. Well, I haven't done it yet, right? I have been looking at I've been looking at the power series representation centered at 0 for f prime of x. So how would I find the power series representation for f of x? Integrate that, right? So if I'm starting with, this is, blue, this is like my thought process. Well, I know that is equal to that, and so if I change x to x squared, then, oh, that looks pretty close to that. But then I multiply by negative 2x, and so this is what I have, right? So this is the power series representation for that thing, which is the derivative of what I'm looking for. So now I just need to integrate that, and I would say that ln of 1 minus x squared is equal to the antiderivative of this. So that's going to be c plus, and then here it's going to be negative 2 times the summation as n goes from, okay, so if I did start at 0, well, I'll leave that open for now. Just bear with me. What's the antiderivative of the general term with respect to x? X to the 2n plus 2 over 2n plus 2. Now here I would say that this is equal to c plus negative 2 times the summation as n goes from, okay, let's talk about this. When n is equal to 0, I don't have my issues here, right? I don't have my issue of having the power be something that is not a positive integer or like a negative value. So we're all good. So this goes from n equals 0 to infinity of, and now this I would say x to the 2n plus 2 over 2 times n plus 1. And then that 2 and that 2 would cancel out. And I would say that this is just equal to c minus the summation as n goes from 0 to infinity of x to the 2n plus 2 over n plus 1. And then I would say, well, so this is ln of 1 minus x squared. When looking at that, when x equals 0, I would have that ln of 1 would be equal to c minus, talk to me about all of these terms when x is equal to 0. They're all 0, right? And this is just 0. So therefore, c equals 0. So ln of 1 minus x squared is equal to, and now you could bring that negative inside if you wanted to, n equals 0 to infinity of negative x to the 2n plus 2 over n plus 1. I don't know if that's what they had. So let me, I haven't found the interval of convergence yet either. Let's go to, let's see if that's what they did. I had x to the 2n plus 1, and I anti-differentiated that. So remember, you always add 1, and then divide by whatever that is. Right? X to the 5th antiderivative is x to the 6 over 6. Yes?
How did you get the summation by which you integrate? I don't see how, when you integrate, it gives you the summation for I of 1 minus
ln.
L.
There is no in, and then you smile, and I correct you on your tests by putting in. It's a natural logarithm. It's the logarithm natural logarithm. So it's ln, which is a very important thing, because if you put that on the AP exam, they're going to mark it wrong. I promise you. Like, it's not like I'm trying to do that sort of thing.